Here's how to hack into your instrument cluster to change the odometer reading. I've got a Lexus ES300 cluster swapped into my Camry. It is currently reading 629,209 kilometers, and I need to reprogram it with the correct kilometers for this vehicle. I'm going to first start by removing the instrument cluster. So here's the cluster out of the car. We need to open this up to access the chip. So I'm going to start by releasing these tabs here to take off the front cover. A couple more tabs at the top here to release. Next I need to remove this white thing by removing 4 screws. I found out the hard way that you don't actually have to remove these needles in order to get the odometer chip out. If you turn this around and remove this board here, and remove all 24 of the screws on the back here, the whole panel will just drop right out. Like that. And then if we go over to the speedometer unit here, we can see the black EEPROM chip that we need to desolder from the board. So here I've got an instrument cluster from a Camry, and I found that once you pop off the clear piece and the plastic bezel, to get access to the speedometer odometer unit, you actually don't need to take off the gauge face. You can flip it around the back and remove these 5 screws here. And then we just turn this over, and the speedometer unit will just pop right off here. This is the chip that stores the odometer information. It's a 93C46 EEPROM chip. It has 8 pins that need to be desoldered from the back of the board, and then we can connect it to a computer serial port for reprogramming. Desoldering the chip from the board here. That's the chip removed from the board. Here's the odometer chip that came off of the board from here. I'm going to solder in a dip socket so that I can easily put this chip in and out when I'm testing my new program. We're resoldering a dip socket to the board. Here we have the microwire EEPROM adapter to connect the chip to the serial port. Over here is a serial port connection. It leads to 4.7 k ohm resistors and standard 5 volt Zener diodes that go to ground. That heads over to the inputs from pins 1 to 4 on the EEPROM chip. And then we get our standard 5 volts from the computer power supply that goes to pin 8 on the chip, and then pin 5 goes to ground. Here's my serial EEPROM adapter. I'm just going to plug in the chip over here and then connect my 5 volts from the computer power supply. And these other connections here lead to the resistors and Zener diodes, and then out to the serial port. I just rigged up a connection to the serial port here because I don't have the correct head. I'm using PonyProg, which is a serial device programmer. It's a freeware that we can use to read information from the serial port. The first thing I'm going to do is set up the interface, make sure it's selected to serial port, SI prog IO, select the serial port that I'm connected to, leave everything else unchecked. We can do a quick probe to make sure everything is okay, and then click OK. Then I need to set my device to the microwire EEPROM, which is the 9346 chip that I'm using. Select that, and then I can click here to download all of the information from the chip. All of the values here are in hex. As you can see on the side here, there's little pointers to the last change that was made to these values. So in this case, it's lines 0 and lines 1 that store the odometer reading in sets of 4, and they're repeated 3 times. So in this case, this section here, 6D, FA, FF, and 9D is repeated here, here, and also here. We needed to edit these values in order to change the odometer reading. Here's how to decode the 8-digit hex characters that you get from the chip. Basically, the middle 3 are unknown. This column here is your tens column, then your hundreds column, your thousands column, your 10,000s column, and your 100,000s column. These are coded here in inverted hex, so what you need is a hex lookup table, which is essentially 0 to 9, and then A to F, inverted backwards from 0 to 9, and then A to F. So in this example here, if we take 6 and invert it, we get 9, we get D to 2, F 0, 6 to 9, D to 2, and then to translate this, the 100,000s column, which has a 6, goes here, the 10,000s column has a 2, that goes here, the thousands column has a 9, that goes here, the hundreds column has a 2, that goes here, and the tens column has a 0. I haven't yet figured out what controls the ones column. I've made a little Excel sheet to find the inverted hex of this value, so I type in the mileage here. In my case it's 265,650 kilometers on my car. Click that and it gives me the inverted hex here, A9, AF, FF, and D9. So then we go to our program, click Edit, and then Edit Buffer Enable, and then we can double click and change the values. So in this case, A9, and then AF, FF, and then D9. And I need to repeat this 3 times. I'm going to double check that the 3 repeated values are the same for the hex characters, and then we can go ahead and write to the chip. This will save to the chip, and then we can quickly verify that, and we're done. Now we can disconnect the chip and reconnect it to the odometer. Here we've got the chip installed in the dip socket. The dot is facing the upward direction. I've also chosen to color this area here with a marker, just to give this a little bit of a different color. I'm just coloring this in here to see if I can change the color of the gauges. I'm just screwing in the tachometer. It's important to make sure the spiral in here doesn't get tangled up. I'm going to replace the fluorescent tube at the top here, and then replace the gauge face. Next I'm going to reinstall the needles. You have to align these 2 pegs here with the 2 pegs on the needles by turning this, and then realigning them. And then flip this over and install it into the casing. I'm going to screw in all 24 of the screws on the back, making sure I put the right ones in the correct locations. Next I'm going to reinstall the circuit board on the back and then the white cover. Finally I'm going to reinstall this bezel, reinstall the clear cover. Now that everything's put back together, I'm just going to record when the mileage was changed. I'm going to reinstall the instrument cluster. Install this trim piece here. I'm going to start it up and test it out. As you can see, the gauges are lit up now in the blue color that I've colored it with. As you can see, the kilometers now read 265,654 kilometers, which is correct for this vehicle. I'm going to take it for a test drive and make sure all the gauges work properly. After testing everything out, it works well. I've actually removed the blue coloring because it was a bit hard to see. Remember, it is illegal to falsify odometer readings when you're selling your vehicle.